Hello everyone and welcome. I am Pushpak Pandit and you are watching me on my YouTube channel Being Bookish. So today I am going to start class 9th syllabus for ICSE board. I know these are difficult times and I recommend that you stay safe and stay healthy. So you are just stepped into class 9th from class 8 and you would be wondering that how difficult is class 9th. I would say no class is difficult, you need to focus on your studies. But I also know that during these times it is not an easy job for you to put your 100% focus on your studies. There might be online classes going on and there might be very much chances of network issues and some or the other things. Okay, so I would only say you that give your 100% towards your studies, because it is class 9 and you have stepped into a kind of higher class from which you need to put your only focus in your studies. If you are having any trouble, so don't worry, because we are here to help you. We are here to help you with the subjects in which you are having some trouble. Okay, so today I am starting with the ICSE class 9th syllabus and let's have a fresh and a refreshing start. Don't worry about how you will understand, because it's my job to make you understand. Okay, and you can give your query anytime in the comment box and I would love to help you all guys. Okay, so basically today I am going to start class 9th ICSE chemistry chapter 1 language of chemistry, and particularly in this chapter I am going to deal with molecular mass, percentage composition and empirical formula plus the empirical formula mass. I know this is the third exercise of your first chapter. I have not missed the first and the second exercise. Let me explain. The first exercise do not contain many things. It just contains some definitions like what is atom, what is molecule, what is valency and like that. One important thing is there, that is how to calculate or how to find the molecular formula, for which I have already made a video. Okay, the link will be given in the description box and you can also find that video link now in the iCard. Now talking about the second exercise, I guess it is about balancing and all that. So I recommend that if you do not have a good grip on balancing, then you can definitely comment down. Okay, now I am particularly taking the third exercise because I think that in all the three exercises, the third exercise is very important. Okay, and I would also say that it is important for class 10th also, because you would have to learn these concepts in class 10th also. Okay, so I have talked much and now without wasting any time, let's start our topics. Okay, so first of all, let's start with relative molecular mass, which is also known as relative molecular weight. It is a very easy concept if you know the atomic masses. Okay, if you know the atomic masses, at least till the first 20 elements. If there is any element which is out of the first 20 elements, then its mass would be mentioned in your question paper. Okay, so at least you should know the mass number of first 20 elements. Okay, so let's directly take one question and try to understand the concept behind this. See, the first question is that find the relative molecular mass of C12H22O11. So we need to find here the relative molecular mass of this compound, okay, or this molecule. So what you need to do here, how will you solve? It's simply, we know the molecular mass of carbon is 12, molecular mass of hydrogen, atomic mass of carbon is 12, atomic mass of hydrogen is 1 and atomic mass of oxygen is 16. It's 16. So particularly we should know the atomic masses of each element. Then our job becomes very easy. How? Let's see. Mass of one carbon is 12. So mass of 12 carbon will be what? 12 into 12 plus. Special mention should be here done is that after every element you need to place one plus sign, means you need to add, because you need to calculate relative molecular mass. That means what? You need to calculate the molecular mass. It is a molecule, so what is the mass of that molecule? So we can find that by adding all the masses of the particular atom which are constituting this molecule. Okay, now hydrogen mass is 1. So mass of 22 hydrogen will be what? 1 into 22. Similarly, I will do it here. Mass of 1 oxygen is 16. So mass of 11 oxygen will be what? 16 into 11. That's it. Now just calculate all the values. So it would be 144 plus 22 plus 176. So I guess the answer for this question is 22 plus 176 is equals to 342. And what is the unit? The unit is this. Don't forget to mention the unit. Okay, so AMU means what? Atomic mass unit. So the relative molecular mass of C12H22O11 is 342 AMU. Okay, I hope that you understood the process. There is not much deep concept, it's simple. Just put the atomic masses of each element which is constituting this whole molecule and then calculate. Okay, see the process and note down. Now let's take another question. Question number 2. Find the relative molecular mass or find the molecular weight of CuSO4.5H2O. It is an important question. So let's see. First of all, the first step which I consider is that note down the molecular masses of each element. Particularly copper is out of the first 20 elements, so its atomic mass would be given, which is 63.5. Sulfur, it is in between 1 to 20. You know it is 32. Oxygen is 62 and hydrogen you know it is 1. Okay, so let's see how to calculate. Just the similar process we will repeat. So copper is only 1. So let's see the process. So copper atomic mass is 63.5 and we have only 1 copper here. Okay, plus sulfur atomic mass is 32 and we have only 1 sulfur here, plus oxygen atomic mass is 16 and we have 4 oxygen here. Now what does this mean? Dot 5H2O. It does not mean that you will multiply this. No, see, this is the mistake which happens, but you do not need to do that. You just need to simply add only. Plus 5 H2O, put this H2O in bracket. So hydrogen mass is 1 into 2 because here are 2 hydrogen, plus oxygen mass is 16 and here are 1 oxygen. For this part you can also do like this. Okay, for this part I am just showing you another way. Okay, how you can do this. So I am putting this here. 5H2O, plus sign will be here, means after this you will put a plus sign, then 5 into here. You know that here are 10 hydrogen. How many hydrogen are there? 10 hydrogen. And how many oxygen are there? 5 oxygen are here. I guess you know this basic concept. Okay, so what will you do? 10 into 1 plus 5 into oxygen mass is 16. You can also do this or you can do this. No matter, everything is correct. If you will calculate, then it will come 10 plus 80, which is 90. And if you will calculate this, I guess 2 plus 16, which is 18 into 5 is again 90. So both of them are going to give you the same result. It's upon you how you can apply this. Okay, so now let us calculate. 63.5 plus 1 is 63.5, 32 plus 1 is 32, plus 16 into 4 is 64, plus this we have calculated as 90. Okay, So the final answer, I guess, is 249.5 MeV. Okay, this is the answer for the relative molecular mass of CuSO4.5H2. So note down the process. I guess this question is also quite clear that how we have solved this process. Okay, so now let's jump into our second concept, which is percentage composition. This concept is also not a hard concept. See, the concepts for which I am making this video are not hard, but little bit calculation are required. So don't make any mistake in calculation. Okay, now let me directly take you to the question, and then you would be able to know what is the formula and how do we find the percentage composition. Okay, so basically what happens is in percentage composition is that you would be asked that how much percentage a particular element has occupied in a given compound. Okay, you know, let me read the question. Find percentage of hydrogen in water. So what is water? It's H2O. Okay, so what is the percentage composition of hydrogen in water? Means how much percentage hydrogen has occupied in the whole compound of water. Okay, this is the question meaning. Now let us see how to calculate. Let us see the solution part. The first thing which you will do is to find molecular mass. You need to find the molecular mass of the compound. So these are the steps which I am providing you. Kindly note down. The first step is to find out the molecular mass of the compound. For this question, the compound is water. So let us calculate the whole molecular mass of this water. So molecular mass of water is what? Hydrogen 1 into 2 plus oxygen 16 into 1. So 2 plus 16 is 18 AMU. Okay. So this is what we need to do in the first step. In the next step, it's nothing to do. Directly find the percentage of the given compound which is asked in the question. So how will you do this? So we have a formula here. So percentage composition is equals to total weight of element divided by total mass of compound into 100% into 100 only. Okay, or percentage also you can write. Total weight of element. Total weight of which element? The element which is asked in the question. For this question, hydrogen. So total weight of hydrogen should be placed here. Total mass of compound. Total mass of the whole compound. So for here our whole compound is water. So we need to put the total mass of the whole compound water here, and then we need to multiply by 100. Why we need to multiply by 100? Because we need to find the percentage composition. So anything if you will be asked to convert into percentage, you multiply it with 100. So just put the values here. So I am doing it here. So percentage composition for particularly we need to find out hydrogen. So what is the percentage composition for hydrogen? So percentage composition of hydrogen is equals to total weight of element. So what is the total weight of hydrogen in this compound? Total weight of hydrogen in this compound is what? 1 into 2. It is 2 gram. Okay. Now divide it with total molecular weight of this compound. What is the total molecular weight of this compound? It is 18 AMU. So divide by 18 into 100. This is what? Total weight. I repeat, not only the simple weight. Simple weight of hydrogen is 1, but what is the total weight of hydrogen here? It is 2 H2. so it is total 2 gram. Now just do the calculation part. 100 by 9, and I guess it will be 11 by 9 percentage. So percentage of hydrogen in water is 11 by 9%, and this is your answer. Okay, so note down. Now let's focus on the third concept, which is empirical formula, and along with the empirical formula I would also teach you how to calculate empirical formula mass. This is again an easy concept. Even I would say that it is the easiest of the two which I have taught you now. First of all, what is empirical formula? So note down just two words for it, that empirical formula is the simplest formula. What is empirical formula? It is the simplest formula. Now what do I mean when I say simplest formula? Let me teach you this with a simple example. Suppose you are asked, find the empirical formula of C6H12O6. Find the empirical formula of C6H12O6. So it would be CH2O. CH2O. Basically what I have done, I have took the common here. The 6 was common, so if I take the 6 as common, 6 1 ja, 6 2 ja, and 6 1 ja again. So this is the simplest formula. It's like a kind of LCM we are taking. Okay, it's like a kind of LCM. Now this is what the final answer is, CH2O. This is the empirical formula. Okay, now let me make your concept a bit more clear by taking one more example. That what is the logic behind empirical formula? Suppose there is a compound which is like C6H12O11. Suppose this is a compound. Now what will be the empirical formula? What will be the empirical formula? I guess CH2O11. Most of you might have done this, but this is wrong. This is wrong. Why wrong? Because whatever you are taking the common, it should be common in all the elements which are present here. It should be common in all the elements which are present here. If you take 6 as common, then 6 is common for this and this, but not for this. So what will be the empirical formula? The question itself. This is the empirical formula, because we can't do anything for this. Okay, but suppose if oxygen was not here, it was just C6H12, then in that case CH2 would be your answer. CH2 would be your answer. I hope your concept is now crystal clear. Okay, now let's move on to empirical formula mass. What is empirical formula mass? See, suppose you will be asked that what is the empirical formula mass of C6H12O6. The first step which you will do, kindly note my words, the first step which you will do is to convert it into the empirical formula. First convert the given compound into its empirical formula, means its simplest formula. Then simply find out the mass of this formula. Simply find out the molecular mass of this formula. So what is the molecular mass of this formula? Carbon molecular mass is 12 plus hydrogen molecular mass is 182 plus oxygen is 16. Okay, so 12 plus 2 plus 16, 14 plus 16, which is 30 AMU. Okay, which is 30 AMU. Similarly, what is the empirical formula mass of C6H12O6? This is your question. So first step which you will do, you will convert this into its empirical formula. Convert, okay, let me write here, convert. So convert it into its empirical formula. Now when you have converted it into empirical formula, then find out the empirical formula mass by just following the process which we have done in finding the molecular mass. So simply 12 plus 2, which is 14 AMU. Okay, so this is just the simple concept behind empirical formula plus empirical formula mass. Kindly note down this. So students, that's all from this video. I hope that you are crystal clear with all the three concepts which I have taught you today. If you are having any trouble in or any doubt in any of the question, don't forget to comment down. And if you are new to the channel, don't forget to subscribe to this channel, because I am going to come up with several more videos upon class 9th related to the subjects like chemistry, physics and maths. Okay, and if the video was helpful, don't forget to like the video. Thank you.